Sam, I'm looking at this machine learning assignment and my brain is stalling. How do I explain how it learns without just saying math?
Think of it like teaching a toddler what a dog is. You don't give the toddler a manual on canine anatomy.
Right, you just point at a dog and say, dog.
Exactly, that's the core of it. ML is just a way for computers to find patterns in data without being told exactly what to look for. It's moving from if-then logic to experience-based logic.
So, if I show it 1000 pictures of cats, it just knows?
If you use supervised learning, yes, it's like a flashcard system. You provide the input, the image, and the label, the word, cat, Alex, and the learning part.
And the learning part?
That's the optimization. The computer makes a guess. If it's wrong, an algorithm, like gradient descent, tweaks the internal settings to reduce the error next time. It's basically a massive game of hot or cold, until the error is near zero.
What if I don't have labels? Like, if I just have a pile of random data?
That's unsupervised learning. The computer looks for similarities. Imagine sorting a giant bin of Legos by color without being told what colors exist. It groups them into clusters.
And what about those AI robots that learn to walk?
That's reinforcement learning. It's the trial and error method. The AI gets a reward for a good move and a penalty for a bad one. It keeps playing the game until it maximizes the total reward.
So once it learns, it's done?
Not quite. After training, you have a model. You then give it test data, stuff it hasn't seen before, to see if it actually learned the patterns or just memorized the answers.
If it generalizes well, we have a working AI. If not, back to the drawing board.
Exactly. It's not magic, it's just statistics at scale.
Okay, I get the categories. But what's actually happening inside the machine? Is there a tiny digital brain in there?
Sort of. We call them artificial neural networks. They're loosely inspired by the neurons in your own brain.
So, it thinks like me?
Not exactly. It's more like a series of layers. Imagine a row of people. The first row looks at raw pixels. They pass what they see to the second row, which looks for edges. The third row looks for shapes, like circles or triangles.
And the final row puts it all together to say, that's a face.
Exactly. Each connection has a weight. If a neuron finds something important, it fires more strongly. Learning is just the process of the machine adjusting those weights until the output is correct.
This sounds like it needs a lot of power.
It needs power, but more importantly, it needs quality data. If you train a self-driving car only on sunny days, what happens when it rains?
It probably gets confused and crashes. Right, we call that overfitting. The model memorized the sun so well that it doesn't know how to generalize to rain. So, the learning is only as good as the textbook, which is the dataset. Spot on. Engineers spend 80% of their time cleaning data and picking features, the specific variables like height, weight, or pixel intensity, that actually matter for the prediction. It's amazing, but a bit scary. If the machine learns from us, doesn't it learn our mistakes too? That's the biggest challenge in milliliter today. Bias. If the data is biased, the AI will be biased. It doesn't know right from wrong. It only knows patterns. So, how machine learns isn't just about math. It's about how we feed it information. Precisely. It's a tool. It's like a mirror reflecting the data we give it. I think I have enough for my assignment now. From flashcards to neurons to ethical mirrors. You're ready. Just remember, it's not magic. It's just very, very fast math.